Partial fraction decomposition, part 3. This time, let's check out this example. In this example, we have 8x cubed plus 13x all over x squared plus 2, the quantity squared dx. Here, as we can see that the numerator is smaller than the denominator because it is x to the 4th, so we don't need to do any division, and this is the simplest form. We cannot break it into factors further than this, and we know that this is the quadratic factor repeating 2 times. So for the first factor, we're going to use some linear numerator here, and for the second factor we're going to use another linear numerator here. So for the first factor we're going to use ax plus b, and for the second factor we're going to use cx plus d to distinct these numbers from each other. And now we know that this fraction is equal to that fraction on the right hand side. Now we're going to solve for a, b, c, d, but before that we're going to multiply the whole equation, everything else, with the LCD. Our LCD is x squared plus 2, the quantity squared, here, this thing. If I multiply LCD with the first fraction on the left hand side, I obtain the numerator here, 8x cubed plus 13x equals to, if I multiply it with this fraction, I obtain ax plus b times 1 factor of x squared plus 2 cancels out this, so I have x squared plus 2 here, plus, and if I multiply this with cx plus d, they cancel out. And if I multiply LCD with cx plus d, I obtain cx plus d times 1 because they cancel out. So now we have this equation here. I'm going to expand it before I give value for x. Or we can match left hand side and right hand side, which is another technique. Okay, so 8x cubed plus 13x is equal to, let's expand this binomial, so it's going to be ax cubed plus 2ax plus bx squared plus 2b plus this term here, cx plus d. Now we can match up left hand side and the right hand side. So this is the cubic form, x cubed, so I have to match x cubed on the left hand side. So x cubed, the coefficient of x cubed is 8, here the coefficient of x cubed is a, so from here a is equal to 8. Okay, let's match up squared. So x squared term is, here is b, we don't have any x squared term here, 0x squared, so b is equal to 0. Let's go ahead and continue with x term. So x term, here we have cx, so c, and we have 2a. So 2a plus c as x term is equal to x term here is 13. From here we can solve for c because we know the value of a. 2 times 8 is 16. 16 plus c is equal to 13. From here c is equal to -3. And d is equal to 0 because this is the constant term. We don't have any constant term here, so d is equal to 0. Now we know a, b, c, and d values, so we can directly place it. So a is 8, b is 0, d is 0, and c is negative 3. So here we get 8x over this factor and negative 3x over this factor. So our integral, which is 8x cubed plus 13x over x squared plus 2 squared dx, turns into integral of 8x over x squared plus 2 dx plus negative 3x over x squared plus 2 squared dx. Now we know how to integrate each term one by one. So here we're going to use u substitution, and here we're going to use u substitution as well. Here let u be equal to x squared plus 2. Then du will be the derivative of this, 2x dx. And if you solve for dx here, dx will be 1 over 2x du. Let's do substitution here and then solve all together. Here u is equal to x squared plus 2, and then du will be again 2x dx. Likewise, dx will be 1 over 2x du. For the first integral, we have 8x over u. Instead of dx, we have 1 over 2x du. Here 8x divided by 2x is 4, and if you pull 4 to the front, it's going to be 4 integral of 1 over u du. We know that antiderivative of 1 over u is ln of u, so it's going to be 4 ln of u, and we know u, we can bring u back, it's going to be x squared plus 2. We don't need absolute value sign here, normal parentheses is okay, because x squared is positive. Plus, for the second integral, we have integral negative 3x over u squared. Instead of x squared plus 2, we're going to write 2, and we have squared here, and instead of the x, we're going to write 1 over 2x du. And here x's cancel out, and we can pull negative 3 over 2 to the front, and we can take u squared to the numerator as negative 2 du. Here we can apply the power rule. We can add 1 to the power and divide it by the power. It's going to be negative 1 divided by negative 1. And divided by negative 1 makes this positive 3 over 2, and this is u to the negative 1, which is 1 over u, which is 1 over x squared plus 2. So if you write in a better form, we obtain 4 ln of x squared plus 2 plus 3 over 2 times x squared plus 2 plus c. This is the answer.